Welcome to another Astronomy Daily with Steve and Hallie. It's the 21st of October, 2024.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
That's right, another episode underway, and we enjoyed a massive hunter's moon this week where I live just north of Sydney in Newcastle, which is on the mid-east coast of Australia. The moon was large and gorgeous.
And you do love that moon, don't you, human?
Oh, and welcome to the studio, Hallie. Yes, the moon is very pretty. Definitely one of my favourite rocks.
I've been perusing the enormous collection of images posted from all over the world.
Yes, people have been clicking away all over the place.
It's taken over from all the excitement we had from the auroras recently.
Yes, it's definitely the latest thing in the sky, and there's more to see coming up in the sky, which I'll be talking about later on. So, Hallie, what is on the menu today?
Well, SpaceX just launched some satellites for a web competitor. Some people might find that unusual.
Well, that does sound a bit odd, but I guess business is business.
And I've got a story about a moon train and robot rovers in development to explore the moon.
Interesting.
I know you'll like that one.
Yep, right up my alley, Hallie. And you know me all too well. Robots, rovers, and the moon.
That's a milkshake made for Steve, all right.
Oh yeah, I love me rocks and me robots.
And now some news bites from the Astronomy Daily newsletter.
Sounds good, boss. Let's have it.
SpaceX launched 20 spare OneWeb satellites October 20th to strengthen the resiliency of French operator UTelsat's rival low Earth orbit broadband network. UTelsat said it had successfully contacted each satellite following liftoff on a Falcon 9 rocket at 1:13 a.m. Eastern from Vandenberg Space Force Base, California. UTelsat spokesperson, Katie Dowd, said the company now has 654 satellites in orbit for the constellation, which already had enough in low Earth orbit to provide global coverage but has been held up by ground infrastructure delays. Dowd said the operator remains on track to start global services in the spring. The satellites are identical to the rest in OneWeb's first-generation constellation, which Airbus US Space and Defense mostly built at its mass production facility in Merritt Island, Florida. UTelsat, which also operates a fleet of 36 geostationary satellites, has yet to say when it plans to introduce low Earth orbit spacecraft with improved technology after opting for a phased next-generation constellation deployment strategy. According to Dowd, the company expects to start deorbiting first-generation OneWeb satellites in the next couple of years as its first batch of low Earth orbit spacecraft near the end of their design lives. Remote control robots could help humanity explore the moon and Mars. Early tests of remotely operating robotics with an eye to employing them on the moon have been promising. Developments seem to be leading to technologies that enable future moon rovers being teleoperated from Earth. Teleoperated rovers could soon be working on the moon, with human controllers on Earth manipulating the rover's tools virtually, allowing for greater dexterity when taking samples, digging or assembling. Researchers from the Robotics Laboratory at the University of Bristol in England have tested their new teleoperation system at the European Space Agency's European Centre for Space Applications and Telecommunications at Harwell in Oxfordshire. By controlling a virtual simulation of a rover, they were able to manipulate a robotic arm to dig a sample of pretend lunar regolith, which is called simulant. The process negates the need for camera feeds, which can lag because of the 1.3-second time delay between Earth and the Moon. The signals between the teleoperators and robotic missions on the Moon could in future be relayed by satellites belonging to ESA's planned Moonlight project. This simulation could help us operate lunar robots remotely from Earth, avoiding the problem of signal delays, said Bristol's Joe Luca in a statement. The virtual simulation also incorporates haptic interactions. In other words, it gives the user a sense of touch, mimicking the tactile properties of lunar regolith in the Moon's low gravity. This gives teleoperators a greater sense of how much force they have to use to dig into regolith, or to lift a sample in a scoop. So far, the haptic interactions have only been included in the virtual versions of basic tasks, such as pressing regolith into the ground or dragging a scoop through it, but not yet for more complex tasks. Does a levitating robot train on the moon sound far-fetched? NASA doesn't seem to think so, as the agency has just greenlit further funding for a study looking into the concept. And here's an acronym that you'll enjoy, Mr. Steve. The project, called Flexible Levitation on a Track, or FLOAT, has been moved to Phase 2 of NASA's Innovative Advanced Concepts program, which aims to develop science fiction-like projects for future space exploration. The FLOAT project could result in materials being transported across the moon's surface as soon as the 2030s, according to the agency. We want to build the first lunar railway system, which will provide reliable, autonomous, and efficient payload transport on the moon, project leader Ethan Scaler, a robotics engineer at NASA's Jet Propulsion Laboratory, wrote in a NASA blog post. He continued, a durable, long-life robotic transport system will be critical to the daily operations of a sustainable lunar base in the 2030s. According to NASA's initial design, FLOAT will consist of magnetic robots levitating over a 3-layer film track to reduce abrasion from dust on the lunar surface. Carts will be mounted on these robots and will move at roughly 1 mile per hour or 1.61 kilometers per hour. They could transport roughly 100 tons or 90 metric tons of material a day to and from NASA's future lunar base. NASA plans to send astronauts back to the moon as early as 2026 as part of the agency's Artemis mission, and aims to eventually set up a permanent lunar base to aid future space exploration. And that's just a few quick stories from the Astronomy Daily newsletter for today. Back to you, favorite human.
Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at AstroDailyPod on X, or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
Space technology firm True Anomaly has selected Firefly Aerospace Alpha rocket to launch its autonomous Jackal orbital vehicle for a US Space Force Rapid Response Demonstration mission, the company's announced on October 7. Hang on, this is a Space Force story, Hallie. Can you grab the theme for me? There it is. Space Force! Invisible! Yeah, that'll do. That's better. Colorado-based True Anomaly will support the military's Victus Haze mission scheduled for 2025 as part of the Tactically Responsive Space, or TAC-RS, program. The partnership with Firefly includes provisions for 2 additional missions, as both companies aim to strengthen their position in the military's rapid response space operations sector. Victus Haze will test the Space Force's ability to counter orbital threats on short notice. The mission involves a complex choreography between True Anomaly's Jackal spacecraft and a separate vehicle from Rocket Lab, which will conduct proximity operations once in orbit. Doesn't that sound ominous? Victus Haze pushes the boundaries further by requiring a launch within just 24 hours of receiving an order, with operations beginning shortly after the satellites reach orbit, Firefly said in a statement. The mission builds on Firefly's September 2023 launch of a Millennium Space Satellite for Victus Nox TAC-RS mission, marking the company's second collaboration with Space Force. Evan Rogers, True Anomaly's CEO, praised Firefly's track record, noting their innovation and agility in the rapidly evolving landscape of responsive space launch logistics and space vehicle deployment. Mission preparations will see True Anomaly complete development and testing of its Jackal vehicle at its Denver facility before shipping to Firefly's processing facility at Vandenberg Space Force Base, California. The payload will remain in hot standby status until the Space Force initiates the 24-hour launch sequence. Once the launch order is given, Firefly must complete payload integration, rocket fueling and launch operations within the compressed 24-hour timeframe.
Astronomy Daily, the podcast. Astronomy, space and science.
Yes, keen skywatchers have enjoyed many stunning astronomical events this year. 2024 has put on quite a show, including a solar eclipse and a lunar eclipse. And coming up in mid-October, the Orionids meteor showers will peak, showcasing meteors direct from Halley's Comet. This year's skywatching peaks with the Orionids meteor shower showcasing bright meteors against the night's brightest stars with connections to the famed Halley's Comet itself. 2024 has been a remarkable year for both amateur and professional astronomers, featuring everything from a total solar eclipse in April to a partial lunar eclipse during September's harvest moon. As the end of October approaches, there's more in store with the Orionids meteor showers expecting to light up the pre-dawn skies on October 20 and 21, weather and moonlight permitting, of course. The Orionids peaking in mid-October are celebrated for their vivid and fast-moving meteors, making them one of the year's most spectacular meteor showers. However, visibility depends heavily on clear skies. Additionally, the light from a waning gibbous moon transitioning from full to last quarter may overshadow the fainter meteors, significantly diminishing the number visible to observers. Orionid meteors appear every year when the Earth travels through the area of space littered with debris from Halley's Comet. Still, a few Orionids should hopefully be viewable in both the northern and southern hemispheres during the hours after midnight through before dawn on the mornings of Sunday, October 20 and Monday, October 21. The Orionids are also framed by some of the brightest stars in the sky, which lend a spectacular backdrop for these showy meteors. Now, here are some viewing tips for the best meteor show experience. Find an area well away from the city or street lights, said Bill Cook, who leads NASA's Meteoroid Environment Office at the agency's Marshall Space Flight Center in Huntsville, Alabama. Cook suggests that you come prepared with a blanket, lie flat on your back and look up, taking in as much of the sky as possible, and in less than 30 minutes in the dark, your eyes will adapt and you will begin to see meteors. That sounds like a good advice to me. Aside from potentially producing spectacular fireballs, the Orionids reflect quite a legacy. Their parent comet is one of the most famous of them all, Halley's Comet. Now, each time that Halley returns to the inner solar system, its nucleus sheds ice and rocky dust into space. These dust grains eventually become Orionids in October and the Eta Aquarids in May if they collide with Earth's atmosphere. Comet Halley takes about 76 years to orbit the Sun once. The last time Comet Halley was seen by casual observers was in 1986, and it will not enter the inner solar system again until 2061. The comet is named for Edmund Halley, who discovered in 1705 that 3 previous comets seemed to return every 76 years or so, and suggested that these sightings were in fact all the same comet. The comet returned as he predicted, and so it was named in his honour, Halley's Comet. So while it takes another 37 years for us to see Halley's Comet, the Orionids offer a glimpse of its past. Yes, the Orionids start winding down what has been an eventful calendar year for skywatchers. There was the total solar eclipse across most of North America on April 8, the alignment of the Sun, Moon and Earth creating a solar eclipse lasting 4 minutes and 12 seconds. The Perseids brought night sky fireworks in August, and the partial lunar eclipse, a full supermoon, the harvest moon, provided some spectacular images. But wait, there's more, as the advertisement says. Other sky-watching events to look forward to in the last portion of the year include the Geminid and the Ursid meteor showers in December, so look forward to those. And that's all we have for another episode of Astronomy Daily. Thank you so much for joining us again.
And don't forget my cousin. Anna will be taking you through the week with her regular presentations Tuesday to Saturday.
Oh, Anna, she is a busy girl, isn't she?
It's a family thing.
Well, I'm glad she's working so hard to bring all the stories from our Astronomy Daily newsletter to the podcast. So check it out, why don't you? And you won't miss a thing.
That's the plan.
Good plan. And we will catch you again for Monday's show next week. See you all.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.